Good morning and welcome to this morning's webinar. My name is Will. I'll be presenting today's webinar and we'll be looking at the VAG or Volkswagen Audi, Seat and Skoda leaking air intake system faults and diagnostics. Please turn your questions on and ask away. Don't be afraid of asking the question. I do not know everything, but I'll try and answer as we go along, or I'll answer at the end there. Okay, let's begin. So we're looking at air intake system faults as described, petrol and diesel engines. So they are slightly different in their diagnostics and in their symptoms as well. So just to run through, these are probably the most common complaints for petrol and diesel engines that we get. Something that I suspect you've seen it before. If you've had Volkswagen Audi and Seat Skoda in. So petrol engines themselves, it's usually engine warning light on it comes with. Most of the time it's poor running, especially at idle, with the faults code stored. Our man there, the P2279 leaking air intake system. Usually you've got a system 2 lean fault, idle air control system RPM higher than expected, and sometimes a random multiple misfire. Now I'll go through these other faults as we go in and why they've occurred. The diesel system there, diesel engines have a slightly different scenario. The engine warning, they come in usually with the engine warning light on, but usually no symptoms. So no driving problems, maybe a DPF light on because the fault's been stored for a long time, but that's only because the fault's been stored for a long time. But usually you just get the one fault code, the P2279, and that's it. So you're left with that one fault code. So let's look at this in a bit more detail. Next slide. So around 50% of the diagnosis is done through theory. I would say that we could get to quite a good position here just by looking at some of the information that is provided to us from AutoLogic and from the customer as well, from the owner of the vehicle. So this is a nice schematic here that you can see. So verifying the fault, very important there, making sure that the fault's present, making sure that it is what the customer says, collecting the information, getting more information from the owner if needed. Don't be afraid to ask. It can be absolutely vital. And it will also shut off a diagnostic path that you may be going down that's irrelevant. Evaluate, stop and think. So evaluating the evidence, and then basically we are just trying to shut off diagnostic paths so you're going down the right route so that we can test the correct things. So test, measure and compare, and then go toward the item that you think is a fault there. Rectify, fix and check the fault afterwards. So looking at this in a bit more detail. So verifying the complaint. It is quite important just to make sure that the customer hasn't described something that is actually something else on the car. I've had it before. But important questions. These three questions are probably one of the most important. It's something that we ask the most here in AutoLogic when we're talking to you. How often does the complaint occur, or how many times does it happen to the owner? When did it occur? Can we actually reproduce the fault? Also, when did it start? That's the start point of a fault can be one of the most criticals there. And has there recently been any work carried out on it? Has it been to other garages, etc., etc.? So this would be just the start of this is vital, really. You can collect so much information and reduce your diagnostic times from this. So let's move on to the next one there. So evaluate the evidence, identify and isolate the fault. So yeah, once you've got AutoLogic on there and you're looking at the fault codes that are in there, you can look, if you click further on, if you're just looking at the engine, for example, and you haven't done a report, then you can click further on into the fault as an arrow forward, and it will give you extended information. It'll give you the initial freeze frame data, which is on the left. Sometimes it gives you even more information there on the right. The left alone is good. We've got malfunction frequency counter. So like we said before, you can compare it to what the customer has said. Engine speed, calculated load, coolant temperature and air intake temperature, all vital for our diagnosis, but we'll go into that in a bit more detail later. The extended information there, again, for this fault code is absolutely critical, again, because it gives you even more information. This is freeze frame. Remember, this is freeze frame data when the fault code happened. So air mass meter readings are on this. At the bottom there, you've got charge pressure specified in actual. Okay, let's just look at the next slide here. The evidence. So we can look at the evidence. The fault indicates the leak in the air intake system, which it does, which sounds pretty obvious, and it usually is. It usually is a quite evident leak in the air intake system, but we'll go into this in more detail because it can be, or it can get a little bit more complicated if we go down the wrong path. This has only happened once. We can replicate the fault, by doing what? The technical information is understanding the components that are incorporated in the system, which we'll go through in a minute. So sensors that actually trigger the fault. Understanding or any outstanding recalls, or technical service bulletins that can relate to the complaint. So sometimes there is a technical service bulletin. So not for faults that we have present. These faults presently are usually physical problems, but in future there may be an update, an engine software update that may rectify the fault. You never know, so it's always worth calling up or calling us up to have a look. And what is the live data we're expecting to see there? What are the values? Where do we find it, etc. So we can go through this, and we'll go into this now. So first, fault code triggering. How does it know that the fault's there, or what sensors does it use? So firstly, on the right there, you can see a typical air intake system for a petrol. We put this up there because it does demonstrate that there is quite a complex, or there's a lot of scope for leaks. A lot of things that can leak there, brake servo, for example, turbocharger system. It all gets quite in depth. So that's more so that we can see how much is involved. The actual diagnosis, or what triggers a fault, it does depend on what type of engine that you've got fitted and what sensors are fitted. So usually with petrol engines, I say usually, they've got an air mass meter. So petrol engines with an air mass meter, the leak in the air intake system is known by using the air mass meter, throttle valve, and the charge pressure sensor there. So a difference in the readings will trigger the fault. So for example, if an engine's running perfectly, the air mass will be reading, let's say at idle, for example. So you've got engine running at idle, the air mass will be given about 2 milligrams per stroke, maybe 3. The throttle angle may be at 3 degrees there, and your charge pressure will be just atmospheric because there's no, the engine's just at idle there. But for example, if the engine RPM starts to rise, the only reason that it could start to rise if there's more air introduced. So the ECU looks at the air mass and said, well, that's staying at 2 to 3 milligrams per stroke. The throttle angle is staying at 3 degrees. Why is my engine RPM rising? So that's why, this is an instance where it would trigger the fault. So it's got an introduction of air elsewhere, so it would trigger your fault code, and that's where we start. Petrol engines with no air mass meter, the air mass meter is actually replaced by a manifold absolute pressure sensor. So just from the manifold pressure, it can figure out exactly how much depression is in there. Thus, it can figure out the fueling, etc. So the manifold pressure, it knows in what state the engine is. So from the manifold absolute pressure sensor, the throttle angle, it does the same thing. and charge pressure obviously as well, sorry. So diesel engines, a little bit different again. So diesel engines are using the same method of diagnosis, but they're using the air mass meter and charge pressure sensor. Because there's no actual vacuum in the system, it's just using pressure. So it uses the charge pressure sensor and the air mass. It knows how much air is going in. It knows how much charge pressure there should be. If there's a difference, it'll trigger the fault. Okay, so the fault triggering is pretty simple in some respects, but we'll go into the sensors a bit more in detail later on. So let's look at petrol engine diagnosis first. So petrol engine is probably more complex because there's more items that can go wrong, if that makes sense, as we saw on the schematic earlier on there, on the last slide. This is kind of like a case study. This is something, so we've got a car in, so let's imagine we've got a car in there and we've done some of the initial work. So the fault has been confirmed, explained by the customer. The fault is happened recently, sorry. No one else has touched the car. The information collected confirms port idle, hunting at idle, revs up okay, and also drives okay, so there's a bit of a clue there. The fault code is present, so the P2279 leaking air intake system, system 2 lean, and idle control system higher than expected. Like I said in the last slide, the throttle valve is, let's say, at 3%, and the idle is going up. It can't control the idle, or the idle is higher than expected, because at 3% throttle, it thinks that the idle should be at 800 RPM, but it's going up to 1,000. So it triggers this other fault with the P0507, hence why that's in there. The system 2 lean, it's got too much air in the system, so it will be going lean at that point. The fault codes all reappear after a road test that you've done. So you've confirmed all of this, gone through the road test. So let's test and evaluate what we know. Looking at the fault code, you can see more information here. So this freeze frame data will actually help you quite a bit. So if we looked in a bit more detail in it, you can look at the malfunction frequency, how many times it's happened, confirm it with the customer again. The engine speed, so just over 1,000 RPM, but calculated load is at 2%. So it is at idle, but the idle's high, so we know the throttle valve's closed. The coolant temperature is high, or not high, sorry, it's at normal operating temperature, and the air intake temperature is quite normal. So the fault is at idle, so that's good. So it's just using the air mass or map sensor and throttle valve at that point. There are no other faults. So the throttle valve, it's heavily monitored. So if the throttle valve was giving an incorrect value, it would come up with a fault. It's a safety item. The throttle valve can't be stuck open, so it's highly monitored. And if there is any faults, then you would be checking these first before doing anything else. The air mass meter. Now, the air mass meter, if they are faulting or giving an incorrect signal, is usually very obvious on road tests. You would find an engine which would be the intermittent kind of jolts when driving, or lack of power. It would feel very strange, usually with an air mass fault, especially if it's happening right there and right now, because it, as I just described just below there, the fault is happening now, so it drives okay. So at the moment, just with the test that you've done, you can almost eliminate the air mass meter. So without lifting the bonnet, looking at this information, the customer information, etc., without lifting the bonnet, we can almost be sure that there's a large air leak. So it's a large air leak because of the fact that it is at 1,000 RPM and the car is hunting. So we know it's a large air leak between the throttle valve and the engine itself. So it could be intake manifold leaking, brake vacuum leak, so a large brake vacuum leak, or the breather system on the petrol run from the positive crankcase ventilation valve. So from this, you can lift the bonnet up and you can be assured you're either going to find a leak in one of these three areas. as we know, intake manifolds, they rarely leak in a big way. Intake manifold runner flaps can leak. I've seen this before, but it's usually a smaller leak. Brake vacuum, it can leak. It's very easy to check though. It's all there, usually quite visible. And the breather system is something we'll go into in more detail in just a second. So looking at the live data here, we can see on the right hand here is the video, and this will show, as it's doing right now, us looking at the live data in the system. So you can go to dynamic requests there, measuring groups, or there might be common measuring groups, etc. So we're looking at air mass here on the petrol engine. Throttle angle valve, you can see there in group 3. So the information's there if you need to check it. So it just keeps running through there. We'll watch it for a bit longer because it is quite important there. That's quite an interesting one, which is the lambda learning values. Not really needed for our diagnosis today, but it's the information that we can look at if you had a long-term mixture problem. And we're just simply just going through the measure groups here, just showing you exactly what's going on. Idle speed, idle positioner, operating status, etc. So it's all information that we can look at there and go further into. While that's playing in the background there, which you can just keep an eye out, it's only really going through what the tools, live data, dynamic requests. At the bottom here, checking for air leaks, there's a link here that you can see in the blue. This is an excellent bit of work that US did on breather system checks, crankcase ventilation system. It goes into massive detail in the actual link that will take you to. But what I've done in the next slides is have a look at it in more detail. It's not in the next slide, I don't think. It's in the one next to that. But I'll just, as you can see, I think this information, we're just looking at the last bit of live data there, and then we're done. So I'm just going to end that in just a second. I think that's it there. Brilliant. So the next one here is quite an important one. So have a look at the air mass there. Look, when the oil filler cap was going off, it was changing quite a bit there. Now it does make a difference. So when you take your oil filler cap on and off, you'll see that the air mass changes there. Look, it just jumped up and down. You see it doing it there. So that's just from releasing the oil filler cap. It's a bit of live data. That it's more a demonstration really than anything else of how much of an effect the crankcase ventilation makes to the system running of the car, or the running of the car. Sorry. It's just really a visual idea of what's going on there. Now, one of the tests for crankcase systems is actually the oil filler cap test. But let's just move on to these. So, like I said, that link that we were looking at a couple of slides ago was telling us about the positive crankcase ventilation valve. So these petrol engines actually run on a negative pressure, and anything with this type, so TFSI engine generation 1, 2, and 3, all run a slightly negative pressure in the engine system. It helps with lots of things, but it's there, but it runs off quite a big vacuum hose that you can see there, the corrugated piece with the blue arrow coming across. And inside there is a diaphragm that regulates pressure. Now on this one you can see the fault there straight away. But in normal running conditions on an idle, you'll be able to remove your filler cap, but it will kind of hold itself down with a medium amount of vacuum. When this diaphragm split like it has there, it will have full intake manifold pressure in there. You won't be able to take it off. I mean, it could almost take a screwdriver to get that oil filler cap off. So bear that in mind. That's a good test of a PCV valve straight away. If you've got full vacuum in the system, it is usually this diaphragm split. Let's just move to the next slide because there's some more interesting bits here. This is another test for other symptoms there. So let's say you haven't got a massive amount of vacuum underneath the oil filler cap there. You may have a leak in the crankcase system. You could, just to confirm it very quickly, disconnect a corrugated pipe and put a blanking plug over the inlet manifold there. Hey presto, it should run fine. If you've got a problem with the crankcase system, it'll fix itself by putting a blanking plate in there. So that's a real quick way of diagnosing this as well, really quick. Because I'll come to the next slide here. This is why you can get a little bit unstuck. The crankcase system, the PCV or positive crankcase ventilation valve is trying to balance a tiny bit of vacuum in the crankcase system. But it's trying to balance it. It was built mechanically for an airtight crankcase system. If the system is not airtight, it will still try and generate vacuum in the system. So if you've got an air leak, you can see these examples are being smoke tested. But if you've got an air leak around the oil filler cap, dipstick tube, or worst case scenario, which we have seen before, it can happen. The rear main oil seal can collapse. Then the PCV valve, sorry, will try and balance the vacuum and give the engine too much air, sucking it all away from the valve housing. So these are some of the highlights from that link there. But if you wanted to have a look at the link, I do recommend it. It's quite a good, it's a very good file to have a look there. But these are the most common areas that we see. So petrol engines, in essence, like I said before, you can pretty much narrow it down. For example, with that case study that we had there, we knew it was either the intake manifold, brake servo, or the breather system. If you blanked off the breather system straight away and had a look at the intake air system, had a visual look at the air intake and the vacuum system, you would probably find it within 5 or 10 minutes. That would be it. And then just smoking the crankcase system if it rectified it after blanking off the inlet manifold and that corrugated piece of pipe. If it corrected it, then you know you're looking at the crankcase, smoke test the crankcase through the oil dipstick tube, and you'll find your leak then. So summing up, let's leave petrols now and let's go to diesel engines. They're a slightly different principle here, a slightly different diagnostic path. The same, in essence, it's all the same. So you are still collecting the information in the same kind of way because it will help us, as you'll see in the next couple of slides. So this is another kind of case study, something that we see quite a bit. So let's just say, for example, we've seen the car, we've got most of the information available now. So the fault was happened, confirmed and explained by the customer. The fault happened recently, no one else has touched the car. The information collected confirms that the fault was sporadic, the car drives okay, so there's nothing abnormal from the customer's point of view. The fault code, the only fault code is this P2279 and it's sporadic. The fault code does reappear, but it is again sporadic. You've road tested it and there's nothing abnormal about the running of the car. Okay. So again, let's just evaluate the evidence that we've got. Again, from the fault, we can narrow down from the freeze frame data. Being sporadic, especially sporadic faults, they're really difficult to reproduce, as you all know. You can test things for forever and a day. Unless it's happening at the point of test, you're never going to see it. Freeze frame data is probably the only way of looking at this, unless you've got a common sporadic fault. Looking at this, so let's just run down the main freeze frame data on the left. You've got the malfunction frequency again. Engine speed, so it was quite a high load, look. You had 3000 RPM at 99% engine load. Coolant temperature was up okay, and the air intake temperature was looking okay. Not abnormal there, so no miscalculations from the ECU. Looking further in detail, if you've got extended information there, you'll be able to see the air mass meter reading, charge air pressure specified and actual. Now these are the ones circled in red that will really determine where we're going with it. If we're looking at pressures, so if you need to look at the pressures, again, look at the live data in the video that we showed, you can see it. This is a slightly different format because this is in common measuring groups, and you can see it. Charge air pressure actual and specified, really important. The specified is what the engine ECU is mapped to see, so what it should be seeing at any given time, any given rev and load, and the actual is what should be being delivered from the turbo, and they should pretty much match. There may be a slight lag, but it'll be pretty matched up, as you will see. Air mass is the same scenario again. You've got a specified and an actual there. Okay, so let's just move on. Let's evaluate what we've got. So we haven't even opened the bonnet on this car. So let's just remember, we've just collected evidence from the customer and evidence from the machine or autologic there. And we know for a fact we can clear the fault. The fault comes back after load, after road test under load. We cannot hear any large air intake leaks. Now this is actually confirmed by the customer as well. So they haven't felt a jolt, a lack of power, or anything. They haven't experienced any smoke nor view from the engine. Okay, so no other faults come back. Another clue, no other faults at all. So it's just this one fault. There's no other information from the owner apart from what we've got. The freeze frame data, you can see the air mass charge pressure readings there. Now there's only two sensors that will trigger this fault. So air mass will usually give you a running issue or hesitation, a lack of power. The customer would be saying it doesn't feel quite right, etc. The charge air pressure sensor is actually and specified. The same with the air mass. Now the information isn't always available in the road test, so really this freeze frame data is going to be our gold nugget of information that we've got. So from the example on the right, if you look at the charge air pressure sensor, actual and specified, the specified, it wanted to see 2,700 HPA. It got 2,000. So it's about a 700 HPA or millibar loss of pressure all of a sudden. Now, we know there's not been a complaint about a lack of power at any time. There's not been any smoke. If it was a large air leak, it would generally, a mechanical air leak would be there all the time. So it's either going to be a boost leak or a sensor problem. But like I say, boost leak, I can't see it at the moment. With the evidence that we've got here, we can see that there's been no evidence that there's been a boost leak. There'd be black smoke, there would be a lack of power. So I'll go for the sensor problem, a sensor or wiring problem at the moment, just from the information that we've got. Because if there was a large air leak, we'd get smoke, lack of power. But what if the sensor is reading incorrectly? So without even opening the bonnet, I would go straight for the sensor itself. So I would say either we've got a wiring problem with the sensor, so a pin contact problem. Remember, we haven't got any other fault codes for it. So electrically, the ECU is happy. So you may have a pin contact problem at the actual connector itself, or it could be a sensor. So that's where you'd go from there on. So like I say, hopefully with this information, you can see that we've kind of almost wrapped up what the fault could be without even opening the bonnet. You could have done the scan in the car park, had a word with the customer, confirmed that it's all correct according to the live data and the freeze frame data, and we could have come to that conclusion. So I hope you've enjoyed it. This is the end of the webinar. My job today was to try and just shed some light on this fault, what's involved, hopefully save you a bit of time on diagnosis. So I hope I've done that. Any questions, like I say, we'll answer them now. There haven't been any just so far, but if you have any questions, please write them down, and we'll endeavour to answer them for you. If not, we'll get back to you. Like I say, this webinar will be posted on the YouTube channel, so you can just go back to it again and look at it. If there's something that you're not sure about, just go back to it and have a look again. Or if you've got a car in with the same fault, please go and have a look again. Excellent. I'll leave it with you. Thank you for watching. Cheers then. Bye-bye.